See the problem. Here the problem is what volume of 0.1 capital M KMnO4, that is potassium permanganate, is required to oxidize 100 ml of 0.2 capital M FeSO4 in acidic medium. It is the problem. So in this problem here you want to find volume of KMnO4. It is required to oxidize 100 ml of 0.2 molarity of FeSO4 and it is in acidic medium. Okay, so here the problem you can solve it in acidic medium. That's why first we take acidic medium. So when you take acidic medium, within the acidic medium, see, so here the problem we want to solve it in acidic medium. So within the acidic medium, first we can take MnO4. So in acidic medium, this MnO4, okay, it is present as MnO4 minus. Here the reaction can be present like this: 8H plus. This MnO4 minus can be formed as Mn plus 2 and 4H2. Okay, so whenever we take in acidic medium potassium permanganate, here the reaction can be takes place as MnO4 minus. It can be changes to Mn plus 2, and here the number of electron transferred is 5 electrons. That's why here N factor can be taken as 1. It is for potassium permanganate. Okay, and next one FeSO4, that is ferrous sulfate. So here ferrous sulfate means it is present as Fe plus 2 form. In acidic medium, this Fe plus 2, it can be changes to Fe plus 3. Okay, so here number of electron transferred is 1 electron. That's why here N factor we taken 1. Okay, so whenever a reaction we takes in acidic medium in between KMnO4 and FeSO4, N factor for potassium permanganate is 5, N factor for ferrous sulfate is 1. Okay, so while solving like these problems we take in milli equivalent form. So we write like this: milli equivalent of potassium permanganate, it is equal to milli equivalent of ferrous sulfate. Okay, so whenever you take this milli equivalent, generally we taken as normality into volume, but here concentration is given in molarity. That's why here you can apply molarity problem. Okay, so according to that, in place of milli equivalent in terms of molarity, we can take like this: molarity into volume into N factor. It is for KMnO4, and as it is we taken for FeSO4. So molarity M2, volume V2, and N factor for FeSO4. Okay, we take like this. Okay, in place of molarity, if normality is present, then we take N1 V1 into N factor, like that. Okay, right, now we see in place of molarity for KMnO4, here molarity is M1, that is 0.1, and V1 volume that we want to find, and N factor for potassium permanganate in acidic medium, the reaction between KMnO4 and FeSO4, here N factor value is 5. That's why you take 5, and here you see M2, molarity of FeSO4, that is 0.2, and for FeSO4 volume is given, that is 100, and N factor for this it is 1. Okay, like that we take the values. Okay, so in this problem, if you want to find volume for this, we have to use milli equivalents, and here concentration is given in molarity. That's why you take molarity, volume, N factor. Okay, right, from this here you want to find V1 value. So V1 is equal to, here what is present, 0.2 into 100, and here 0.1 into 5 is present, 0.1 into 5. Okay, so you see 5 1 is 5, 20 is 0.2, 0.1. Okay, this can be written as 2. 2 into 20 means it is nothing but 40 ml. So here the answer is 40 ml. Okay, so it is the answer for this problem. Okay, here you see the problem is volume of KMnO4 we want to find, and here the second compound is given in FeSO4, and the medium is acidic medium. Okay, so whenever like these problems are given, first you can see it is acidic medium or basic medium. After that we write the balanced equation. In that, how many electrons can be transferred, that can be taken as N factor. In acidic medium, if KMnO4 is involved, N factor for KMnO4 is 5, because here 5 electrons can be transferred, and ferrous sulfate, here 1 electron can be transferred in acidic medium. Okay, so by taking these we can solve the problem. From this volume we get 40 ml. Okay, so for this problem the answer is 40 ml.